All right, everybody. Now, we need to talk about measures of variation on data. Okay? So, right now, everything that we do starts with data. And, well, where do we leave off before? We were measuring the mean. And the mean tells you what a typical data entry is like. That's one way to look at it. It can tell you the center or middle of the data set, where the data is, where it's located. Those are different ways that you can think about the mean. But we have to measure something else called variation. Variation measures how spread out the data is. Okay? Can you imagine that if, I don't know, you made some measurements. Say you're a vet and you weigh all the cats that come in. It might be that all those weights of cats are fairly close to each other. Or it might be that they're really spread out. It's who knows. That's why we do statistics, because we like to know things like that. Okay, we like to know on average how much does a cat weigh or something like that. And since all cats don't weigh the same amount, how spread out are the weights? Okay. All right, like, is there a big difference between like the lightest cat and the heaviest cat? That would be, one way to think about the spread. Now, what's the stat cats have to say? Let's look at some examples. Okay, I think the best way to see why we need to measure variation is to see some examples. And the stat cat seems to agree with me. So let's take two data sets. Okay. And these are small, and these are just numbers. It's not like I say I measured something or did something. These are just numbers, but they'll get my point across. Okay, data set number 1, 4, 7, 8, and 5. And then another data set number 2, 1, 2, 3, and 18. Now, these have something in common. The mean is 6 on both of them. What's the mean? Okay, well, you add up all the data entries, 4 plus 7 plus 8 plus 5, and you divide by how many data entries there are. Okay, well, that turns out to be 6 on both of them. But these numbers are all different. And even though these two data sets have the same mean, or have the same center, I guess you could say, the numbers are way more spread out in this one. Okay, now if you're a visual, you can look at it like this. So here are the data entries. 4, 5, 7, and 8. And then the mean is right there at 6. So the little dots are the data entries themselves. And then I tell you where the mean is with respect to them. See how it's kind of the middle? There's some on the right, there's some on the left, so on. And then over here, here's that other data set. 1, 2, 3, and then 18 way out here, still with the mean of 6, where this 6, the mean, is roughly the middle. Now, they have the same mean, they have the same average, but you look at it like these numbers, these data are way more spread out than those. Okay, so the data sets have something in common, and that's the mean, or the center if you want to think of it that way, but the spread is very different, and that's what we're after in this video. How do you measure the spread? Okay, how are you going to tell somebody that these numbers are way more spread out, and here's how? Now, the simplest way that you might think is you'd say, well, look, these are more spread out because this is 18 and that's 1. So like the littlest number and the biggest number are far apart. And that's one way to do it. And so that brings me to how you do this. Okay, so we want to measure the variation or spread of data. Variation is the proper word for it, but I might say spread sometimes. Now there's 3 ways. The range, and then the range is fairly simple, I would say. And then 2 other things that can be a little complicated: variance and standard deviation. Okay, so the range is the one you may have already thought about, and that I hinted to on the last page. But the range of a data set is the largest data entry minus the smallest. So here are the data sets I was using already. Remember? 4, 7, 8, and 5. Well, okay, the biggest is 4. The biggest is 8, the smallest is 4. The range is 8 minus 4, or 4. That's the range of this data set. That number tells you how far apart the biggest and smallest are. Look at this one. Remember this one? You'd say there's a lot more spread in this data. Well, that's because the largest entry is 18 and the smallest is 1, so the range is 17. See, 17 versus 4, these data are a lot more spread out than these are, okay? So the range, well, there's not much to the range, okay? Let's look at these other two. Let's see, so check on the range. What about the variance and standard deviation? Okay. So this will look intimidating, most likely, but I'll show you how to do it. It's not nearly as hard as it looks. A lot of math is actually like that. When you see mathematical symbols, to some people at least, it looks like it must be really complicated. But once you figure out what all the symbols mean, it's not nearly as bad, okay? So this might look bad, and you might be intimidated, and you might be a little bit worried about whatever we're going to do next, but these aren't that bad. And then I'll make another video to show you how you can get StatCrunch in my math lab to do all the work for you anyway, okay? Now, all right, but I think everything starts with knowing how to do things on paper, all right? That's my belief. I'm not against calculators. I'm not against knowing how to use technology and make life easier. I'm not against any of that, but you know, I do think if you're gonna understand what all that means, it all starts with paper and pen or pencil. Okay, so let me see. How about this? I'll show you how these formulas work by doing an example. Okay, all right, so let's use the same data set, 1, 2, 3, and 18. Okay, that's one of the ones I used already. Now, the mean, variance, and standard deviation are represented by these Greek letters most of the time. And do you see how that one looks like a U? Well, that's actually a Greek letter. I have such a hard time writing it. It's more like that, but it's a Greek letter mu, okay? And then do you see this symbol right here? This is sigma squared and sigma. So those are also Greek letters. So normally we let mu be the mean. That's a symbol for the mean. Sigma squared will be the variance, and sigma will be the standard deviation. Now let me show you how to calculate these, okay? All right, so first starts with the mean. How do you find the mean? Well, you take the data entries, you add them together, and you divide by how many data entries there are. So let's see, 1 plus 2 plus 3 plus 18. And there's 4 data entries. That's 24 divided by 4, that's 6. The mean's 6, okay? Now, what this formula for the variance says to do is you take each data entry, subtract from the mean, square what you get, and this symbol means add all those results together, and then divide by how many data entries there are. Okay, so here's what I do. Remember the mean 6. I take each data entry minus the mean, I square it, I add them together, and I divide by how many there are. So I do 1 minus 6 squared plus 2 minus 6 squared plus 3 minus 6 squared plus 18 minus 6 squared. Add all that together, divide by 4, and you'll get 48.5. That's the variance. That's this. Data entry minus mean squared, add all together, divide by how many data entries there are. Okay, maybe not so bad, remember? Maybe that looks complicated, but you know, maybe it's not so bad. 48.5, so that's the variance. And then all you do to find the standard deviation is take the square root of the variance, okay? So the standard deviation, sigma, will be the square root of 48.5, which is about 6.96. Okay, so yeah, maybe not so bad. I mean, if I had like a data set with 50 entries, doing it on paper, that would be different. That would be much harder, and I would want to use Excel or StatCrunch or something like that. I don't own a graphing calculator. Personally, this is the only calculator I have. But if you have a graphing calculator, it can do these calculations for you. You just have to enter in the data. All right. But yeah, you could use StatCrunch, and since you have my math lab, it's StatCrunch is built in, and you can just do it that way. Okay. Now, some time for some fine print. This is how you measure the variance and standard deviation for populations. I made another video about what a population is and how a population is different than a sample. Okay, so be careful. The formulas for variance and standard deviation are different for a sample. So what I just showed you was how you would find the variance and standard deviation for a population. The only difference for a sample is I would divide by 1 less than the number of data entries. That's it. Okay, so on, if I considered this to be a sample, I would divide here by 3 instead of 4. That's it. Okay, all right. So if we're dealing with a sample, these formulas work the same way as I just showed you, but we're going to divide by n minus 1 instead of n. Okay, now, so that's how you find the variance and standard deviation. If you use StatCrunch, it will be these sample formulas, okay? The formula, the calculation, or whatever that's built into StatCrunch is these. It's intended for samples, which is what you'll see most of the time anyway on your problems, okay? Anyway, okay, so let's see. Let's do this. Let's do like a little summary here of what these things are as we look back, okay? So standard deviation, this thing right here, whether it's for a sample or a population, measures the variation of the data set about the mean. Okay, I see. That's why we do it this way. That's why we take the data entry minus the mean. That tells you how far apart it is from the mean. See, like we did 1 minus 6, then 2 minus 6, then 3 minus 6, then 18 minus 6. All those minuses measure how far the numbers are from the mean. Okay. Now there's more to the formula than that, but that's where you start out with it. So what these do is measure the variation or spread of the data about the mean. So it's not just the spread of the data, but it's specifically from the mean, from the middle, right? The mean is, you could think of the center of the data set. And as data entries generally are farther from the mean, the standard deviation will get bigger. It will increase. And if the sigma is 0, if the standard deviation is 0, all data are the same. So let's look at it like a spectrum here. If the standard deviation is 0, if sigma is 0, there's no variation from the mean. And that would be like all the data entries were the same number. But if sigma is a big number, if the standard deviation is a big number, then there's lots of variation from the mean. And, it could be somewhere in the middle. But 0 is as small as it gets if there's no variation. But, the bigger this gets, the more varied the data are from the mean.